Hello, Blessing Agaba is my name, and I'm here to continue on the series of my project, Fashion Assistant. And this project is about recommendation of fashion products. So, beginning with, we are going to do data cleaning and exploratory data analysis. And data cleaning involves cleaning of data. It involves checking for values that are either repeated or that are poorly mapped, values that have errors and all that, and then we can correct them by either deleting or adding values for those that will be now. An exploratory data analysis involves exploring your data by plotting, for example, graphs where necessary, histograms, like for the feature independence plots. We have the correlation matrix. We have the heat maps, box plots, and beginning with heat maps. This like a visual representation of correlation matrices. And what are correlation matrices? First of all, correlation matrices, these are tables which display correlation coefficients, and we are able to see which variable is more correlated with the other. For example, label has a correlation coefficient of 1, meaning that it is so much correlated with the other. Their label is very much correlated with label, but label with pixel 1 is not we can see that the value lowers because they are not very well correlated. And this can be represented by heat maps through color, in that you can easily see it, in that the more correlated ones have a lighter color. For example, label with label, the color is lighter. And my heat map is actually my box plot. Most of them are quite complex because I did not reduce my data. I used all my data features and rows and columns. That's why my images are kind of complex. So thinking about box plots, this is a type of chart that displays the distribution of data based on a 5-number summary. That is upper quartile, lower quartile. We have mean, minimum, and maximum, and not forgetting the median. So this can be used when you have 2 or more data sets from independent sources that are related in some way. And we have the feature independence plots. These ones actually, they are feature independence. It means the features are independent, like each feature can actually work without the other. But for my data set, I have pixels, and for you to actually create an image to output something like a fashion product, since it's contained of images, the pixels actually have to work together to produce the final output, which is the image. So for this case, I will not need a feature independence plot. Outlier plots involve values that are actually they are unique from the rest. They are significantly different from the rest. So this will bring errors in measurement, bad data collection, or show variables not recorded when collecting data. And moving on to illustrations of patterns of interest. This is illustrating patterns that in terms of graphs, maybe histograms or bar graphs, and they describe patterns in the data. So for example, in my data, we have uh, numbers that represent fashion products. For example, 2, 1, and they are up to 9, and then 6,000. We have 6,000 images, and each fashion product has 6,000 images. That's why you see like my patterns are actually uniform, like because every product has 6,000 images. If if the images were different, the pattern would be different. Talking about illustration of trends in time and space, this would actually apply to my data set because fashion-wise, with time, the products change, and space, for example, where I collected the products from, like the data of the products from, For example, if if for the space, if it's a different environment, like there's a party and then there's school, definitely they will vary. But the fact that my data set was actually got from one, which is an online shopping platform, I could not be able to illustrate. And also the time, I did not have a time I did not have time in my data set, so I was unable to illustrate the trends in the time and space. Though actually my data can actually be able to do that. And then we had the splitting of the data. The splitting of the data was done by this code. I did the splitting of the data. It was a training data. I had training data already. According to my data set, I already had training data, already had testing data. So all I did was to actually get the validation data, from which I got the validation data from the training data, and I was there. That's how I had to split my validation data into the training data. We have fitting the model. This is fitting the model so that it can actually, after building our model, we compiled it and we had to fit it so that it could do what we want. Tuning of hyperparameters. This is basically defining hyperparameters, and it is shown below. Evaluating the validation list, the validation set. This is done after we are done with everything, after we have split the data, and after we split the data, we can evaluate and see the accuracy level, we can evaluate and see the loss, and yeah, basically that's it. The accuracy level and the errors. The loss is like the errors. Thank you for listening, and thank you for watching.